Responding to this part, and maybe somehow Sipser talks about matching, that maybe somehow what's going on with the U part and the V part, somehow they match. Now in this case they match in the sense that the ends are the same. So the number of zeros and the number of ones match. Okay? Now that's a bit vague, but doing this kind of thing may allow you to generate a grammar that that can do things that a finite automaton cannot. Okay? So if you do have a string where there's some kind of matching, that's a vague term, agreed. But when you get this kind of thing, you might be able to try a substitution rule in your grammar like this, that's recursive, where what's going on the left hand side here and the right hand side here of R, either side of R, somehow match. That's a bit vague, but you know that can be useful. Doing that kind of thing. Right, now for even harder to specify, like from the earlier comment, in general it tends to be thought that designing grammars is thought to be more difficult than designing automata, DFAs. Now, we soon, well, in fact here, we'll start talking about ambiguity. That means that your grammar can generate a string that has two different parse trees. Hence, like two different meanings, but it's the same string. Now, earlier board, when we're talking about arithmetic expressions, we had a grammar there, G4. I think it was G4. Let me just check. So, previous board. What was the number of the grammar? G4. Now, that particular grammar, it involved parentheses, and the use, the strings that came out of that grammar, generated by that grammar, involving parentheses, that the use of those parentheses in the strings matched the usual precedence rules in arithmetic. Remember, precedence just means priority, like which precedence rules tell you which symbols you get operated on or get used before others. Like I think I mentioned last time, like for example, a string 2 plus 3 times 4. Now is that 14 or is it 20? Okay. So it depends which operator you apply first. So do you apply the plus first and then the times, the multiply? So if you do the plus first, you'll get 2 plus 3, that's 5, times 4, that's 20. Okay. If you apply the multiply, the times first, you will get 3 by 4, that's 12, and then you apply the plus, so it'll be plus 2, that'll give you 14. Okay. So precedence rules tell you in arithmetic, do the multiply first. Okay. Unless you've got parentheses around a term, then do the parentheses. Do the term inside the parentheses. The pair of them. The left parenthesis, the right parenthesis. So evaluate the term inside the parentheses first. Okay. Now the grammar was doing that. So how did the designer of the grammar know how to design the grammar so that it would obey the usual precedence rules? And that's what knowing how to do that kind of thing. That's what this fourth tip is about. So you may, in your strings, they may have a certain how can I put this? Certain aspects that are recursive. Well, again, I'll keep it concrete. In grammar G4, there was, let me actually get it. There was a variable called term, I think. Sorry. Well, so we'll say the variable called expression, EXPR, and there was a substitution rule that expression arrow expression plus term, or term, and then the substitution rule for the variable term was term arrow term times factor, or factor. Okay, so the variable expression EXPR, that's recursive because you had the substitution rule EXPR arrow EXPR plus term. So there's one substitution rule that's recursive, and the other example was term itself. So term, the substitution rule, term arrow term times factor. Okay, so when you have that kind of recursive phenomenon in your grammar, how do you know? How do you construct the grammar in such a way that that the strings that grammar generates has the recursive properties that are the way you want? For example, you may want them to obey the normal precedence rules for arithmetic, for example. How do you do that? Well, now this is a bit woolly and vague, but the basic idea, I hope I'm saying words because it's a bit hard to understand. That's often the way with Sipser, I'm noticing increasingly. What you do is you in your grammar you will allow a recursive definition to be placed in the grammar, in the position in your rules in the grammar, that would correspond to the positioning of recursion in the string that you're talking about. I don't know if that's any clearer than the way he's put it. Well, the following comment may help. Now we did in exercise 2.4. Sorry, example 2.4. That was grammar G4. Okay, so go back and forth between this statement and that example. If you actually look at the grammar used to generate these arithmetic statements and the positioning in the rules where the recurrence will occur, and maybe the positioning of the variables that will expand out into recurrent components of a string, that you'll see why the designer has, well, I hope so, you'll see why the designer has chosen to put those variables in the position that the designer has, and the choice of the position of those variables in the rules is such that the recursion will expand, grow out of the initial position of where you put that variable in the first place. The variable that that has a recursive component to it. Well, good luck. So sometimes I wonder, is it just is it Sipser who's just not clear, or is it just the nature of what's being discussed is inherently not clear and hence difficult to transmit? I don't know. Anyway, right, next topic, ambiguity. Now, something that pops up quite a lot in grammars and the languages generated by grammars, in other words, a set of strings generated by grammars, is you may get ambiguity. Now, in ordinary English, let me give you an example of a nice little sentence that came up in. If I can find it quickly. Yeah, just a minute. I need to get it out of the camera. Now, in ordinary English, here's an example of an ambiguous sentence. Ambiguity in ordinary English just meaning the meaning is not clear. Maybe there are two meanings, maybe two ways you can interpret the sentence. Here's an example in English. The girl touched the boy with a feather? Flower. Not that it matters. The girl touched the boy with a flower. Now, can you see that that's ambiguous? The two possible meanings. One is the girl was holding a flower, and with the flower she touched the boy. So in other words, the flower touched the boy. Okay? Now another meaning is the boy had a flower, and that boy was touched by the girl. So the girl, not the flower, the girl touched the boy. Okay? So there's two meanings to that sentence. It's ambiguous. This is more for non-native English speakers. Now actually that particular sentence we will come across later sessions. It's actually an example of a string generated by an ambiguous grammar. An ambiguous grammar, you can probably guess, is a grammar that is capable of generating ambiguous strings. But I'm getting a bit ahead. Alright, okay. So what is ambiguity in this context, in the context of CFG's grammars? So sometimes you'll get a grammar that generates the same string, but with two different parse trees. Okay? So if you have the same string that's generated by two or more different parse trees, then that's called ambiguity. So the same string with two or more parse trees. That, by definition, is ambiguity. Right? So, next session.